the doors has closed, so you're stuck with me now, I guess. All right. 6 safe refactorings for untested legacy code. That's a bold claim, and it requires a bit of clarification and introduction, just to make sure we're all on the same page. First of all, when I say refactoring, I mean it by Martin Fowler's definition of it. Refactoring is the kind of word where we all use it and sometimes abuse it. When we say we refactored this code and I fixed all the bugs. Yeah, well, here maybe you have refactored the code and then fixed the bugs, but if you change the behavior of the code, you are not doing refactoring. Here, I'm going to show you changes of the structure of the code, how the code is written, but I preserve the existing behavior, bugs included. How do you know that after you change some code that you did a refactoring per this definition? Well, you test before and after. So there are different strategies on how you do that. Maybe you test manually, you know how the code was working before, how the system is working, and then you do your change, and hopefully you verify after that it's working. You can do that manually. If you don't, the end user at some point will test it for you. It's better if you have automated checks, so test, but anything like linter, if you're working with a statically typed language like TypeScript, for instance, versus JavaScript, you can consider TypeScript errors like automated test failures. Basically lean on automated tools to give you feedback about did you change something in how the code is working. If you're a TDD practitioner, you will generally refactor once the tests are passing. So you change the code here, and your goal is to keep the test green, so you know nothing has broken, especially that you have written the test before the test before writing the implementation. So you should have as a side effect full coverage. Okay. What if the code is not tested? In my experience, this is actually very common. You have this code. You do not have the automated test. Per Michael Feather's definition in this great book, you're dealing with legacy code. So Michael Feather's definition is legacy code is code that is not tested, which is a good enough definition most of the time. Personally, I would add some nuances because I've seen code that is tested but hard to maintain. It's a different topic. So first of all, it's actually, in my experience, quite common to be in this situation. And the trick here is to be safe, your refactoring should be covered with automated test. But you are in a situation where you do not have the test. And to write the test, you may need first to change the code a little bit. This is the paradox of legacy code. You kind of have this circle of you need to refactor so you can write a test, but it will be better if you add a test to verify your refactoring. So where do you start? What do you do? The thing is, it's not like everything. It's not black or white. People tend to focus on, well, either I'm doing a refactoring that is covered with test and I'm safe, and even here you may not be safe, by the way, or I'm just doing changes and YOLO. We'll see. Hope for the best. The truth is, it's a scale. There are nuances, and the goal here is to bring you to more safety. Maybe not the safest, but safer. So if you do not have tests, you don't have to just cross your fingers and pray or do not touch this code. Better than just doing random changes in the code will be to follow a proven recipe. That is Martin Fowler's book on refactoring. It's really a cookbook. You have 66, I think, refactoring moves. It's a catalog of recipes with step-by-step. Here's how you do it. And a lot of what I'm going to present is based on that. So we're going to follow recipes. Even better if you can rely on automated tools. I'm not sure what kind of editor you're using. In general, people are either using an IntelliJ editor or VS Code, very popular VS Code, especially in JavaScript, TypeScript. These editors can do things for you. So my name is Nicolas. I'm speaking here because legacy code is kind of my specialty. I myself, I'm using VS Code a lot. I was also a very good WebStorm lover. And when I migrated to VS Code to use the same tool as my team, I noticed some things were missing. So I developed my own extension to bring automated refactoring. So this is a topic I've worked with for a long time. Some of you may know me because I'm also very active here in Software Crafters in particular, where we talk a lot about how do you deal with legacy code. So I know the pain. All right, I have 6 recipes for you. I had to decide among all of this catalog which ones are the most useful, especially in this situation. You're dealing with untested legacy code. Which one should I show you? So I have 3 refactorings that are very core basic moves, bread and butter, that I need to show you. Maybe you know them already. I am not sure you know them this way. Then we're going to see another one, change signature, which is a core refactoring, but it's interesting because it's using the other ones. So I'm going to show you how you can compose these little moves into bigger moves. And finally, the distill and extract and extend and override, last 2 here, are going to be, so these are not very popular recipes, but they are very useful for legacy code in particular. Let's dive in. So inline. I'm starting with inline, which can feel weird because sometimes for some people it feels like defactoring. When would you inline code? It's actually very useful for cleaning up. Sometimes you have abstractions that are not useful anymore. Sometimes as a result of another refactoring. And I like this one because it's probably the most intuitive one, the one that everyone knows how to do correctly today. So let's consider this. We have a class, 2 methods. And this method is annoying because we would like to refactor the other one. But we have this thing with the item name. And we'd like to do some strategy around that in the update item quality, but the condition is nested inside that method. So the abstraction we have today is not good enough anymore. So we would like to undo this abstraction to redo it later, maybe. So we're going to inline. Inlining a function, there's going to always be it depends. Is it safe? It depends. In this case, I picked an example that is safe enough. So the first step will be to replace one occurrence with the body of the function. Of course, that depends because if you have throws, if you have return statements, you need to adapt. It depends also on your language. I'm showing JavaScript here, but it's not always the same. However, the approach is the same. First, you replace one occurrence with the body of the function. And you repeat that for every single occurrence you need until eventually maybe your method is not used anymore, and this is when you remove it. This leads me to one interesting point that I'm going to repeat you again and again. It's always the same mindset. First step, we create whatever new code we need. In this case, it doesn't apply because we're inlining, so it's a simpler refactoring. Then we replace each occurrence one by one. Finally, we remove the old stuff. If you're familiar with blue-green deployments or really doing anything at swapping something that is running without breaking anything, it's always the same approach. Inline should be automated. In IntelliJ, it is automated. You have a shortcut, and I really encourage you to learn the shortcut and make it part of your muscular memory. If you're doing VS Code, you should install my extension because I have this. Otherwise, no, it's not automated. But it's the kind of refactoring that you like to just hit a shortcut, and it does it for you, so you don't have to do it manually. Inline, the first one. Basic. Okay, let's step up and go with rename. Why do we rename? Rename is a core refactoring. You know that naming is very hard. And again, people are like, either it's a good name or it's a bad name. The reality, again, it's a scale. I really like this article, so you will have access to the slides. I pointed you to a series of articles by Carlo called Naming as a Process, which gives a different perspective on naming things. And basically it says, you don't have to get it right the first time, it's okay. The worst scenario you have is a misleading name, like parse XML, but the function actually does some side effect and all the stuff that is not parsing XML. And when you read that, you're surprised. So better than a misleading name will be obvious nonsense, something that does not make sense. We're going to reuse that, by the way, later. It's actually a useful technique. And then we want to go for honest and intention-revealing names. But you can stop on that scale and be like, OK, it's better than before. I'm going to put a ratchet here and move on. To do that, you need to be confident with renaming things in your code base. I'm starting with the shortcut right away because personally in practice, and this is native IntelliJ VS Code, whatever editor you use, I hope you have a shortcut to rename symbols right away, regardless of the language. Otherwise, I'm going to show you how to do it safely. But personally, I never do what I'm going to show. I use F2 on VS Code. It works. Use it. OK. Let's pretend you don't have anything automated. I want to show you how to make it safely, because I notice some of my coworkers sometimes I want to rename a variable. OK, if it's only used once, it's no big deal. It's easy. The problem is at scale, like everything. Imagine you have this dfrq here variable. I don't understand what that means. At the beginning, at least, I'm reading this code. I don't understand what it stands for. The problem is the code is actually very long, doesn't fit on the slide, and I have many occurrences. Surprisingly, a lot of developers would just try to start renaming the first one, so change the name, and then look for the second one, change the name, the third one, change the name, yada, yada, yada. It takes time. And the chance to be distracted, see something else, be interrupted, and then go back and forget and do a regression is high. Especially here, this is JavaScript. It's not TypeScript, so nothing has your back. Worse, if it's exported and used everywhere in your code base, you cannot even rely on search and replace, because you may have to consider, OK, this is a common name, and is this the correct reference, yes or no? It takes a while. People just don't rename things. I'm going to show you another approach that is not faster, but safer. The first step, so exactly what I said, I just forgot to move on. After working a while with this code, I realized, OK, a better name will be dice frequency. DFRQ actually means dice frequency, but it's 2024. We're dealing with JavaScript. Let's express ourselves. OK, so the first thing we do is we declare a new variable that's going to act as a proxy just below the first one. And now we're in a position, so we have created new code. Code is actually more complex than before. There is a new statement. But now we can start doing whatever we're doing and rename the first occurrence. The difference is the code is not broken. I could stop here. And I continue. So I keep doing the same work, keep replacing all of these references until I'm done. The main difference is that if I'm distracted or I need to stop or evaluate, is this actually something that needs to be replaced, I can stop. I'm not in a broken state. Finally, eventually, that first initial variable is not used anymore, but by the proxy. So I can inline it. Just use the shortcut, muscular memory, or you do the manual inline. All right, that's it. We have renamed manually a variable. See, it's always create the new thing, replace each occurrence, important because you can stop at any time, and finally you delete the old code. OK, let's move on to extract. Extract is probably the refactoring I use the most. So if inline is undoing unnecessary abstractions, extract is creating new abstractions, so very useful when you're dealing with code. Use the shortcut if you can. It is one of these refactoring that should be automated. IntelliJ has it automated, of course. VS Code, it depends on JavaScript. Extracting the function, yes. Extracting a variable, yes, but the user experience not that great. I'm going to show you with the extension. It's just a shortcut away. What if you don't have it automated? How do you do that safely? OK. I see two main use cases for extracting things. So the first one is you want to clarify the intention. And this is more me doing a sidestep of, OK, there is a refactoring, but why would you do that refactoring? This one, I think, is overlooked. So consider this statement. Anyone, I'm sure, can read and understand that code. The question is, do you understand what it means, that condition? I don't, but it certainly expresses something because it's not a very trivial condition. So let's put that in a variable, at least, or we could extract that in a function. And at this point, I may not be sure about what it does exactly. So how do I name it? I can use a nonsensical name that will be obviously wrong, so I'm not blocking myself from doing the extraction in the first place. And I think that is something we don't use enough. I can do the extraction first and then think about the name. So going with applesauce, go with whatever you want. Applesauce is coming from our Belchi's suggestion. Could be foo, could be bar, whatever. I wanted to do an extract variable. So I did the extraction here and I replaced the occurrence. Eventually, I know what it is. And you know what? I know how to rename. I press F2. And this is when I do it. So you can separate and compose the refactorings together. Let's see another example. This time I'm going to extract a function. So the second use case, and probably the most obvious one, is, well, you have duplication. That is actual duplication, not accidental. But here, for example, anytime we update the quality of the item, we do a verification on the current quality, so we never go over 50. Could be written differently. We could use some matmin, whatever. The problem is the intention is the same. We want to increase the quality. There seems to be some business rule about it. It is duplicated. If we need to change it, we need to change it everywhere and not miss an occurrence. And also, we could reveal the intention. So let's extract that in a function this time. First step, if you're doing this manually, is to declare the new function. Like, you don't start breaking the code and cutting the code away, and now the code is broken, etc. You first start fresh. I'm going to create my function, take that time to polish the signature. I'm going to copy the body of the code I want in the body of that function. Take that time to adapt the signature. And at this point, I can stop anytime because the code is not used. Once I'm happy, I'm going to start replacing the occurrences with this. So here, increment quality. Here, you can stop anytime. It's fine. And complete. You go across your code base wherever that is relevant that you can identify today. Of course, all of these refactorings better if you have tests. But I'm going to show you that what you can do when you don't. I really encourage you again to use the automated version because even if it's not tested, it's kind of reliable. It's more reliable than trying to just do it manually. So it's always the same recipe. The only difference here is we don't remove anything because so it's the reverse of inline. We extract, so we create new abstraction. But first we create the code, then we replace. Do not break the code. OK. Again, it is extracted. I have enough time to show you, because that was a lot of slides and cool animations, but I want to show you how it feels in an editor. So, OK. You may recognize some of the code before. It's longer because I don't have to fit it on the slide. But with the 3 refactorings we have seen today, you should be able to do things like, OK, wait a sec, so you can see the shortcuts. OK, so the way I would usually work with code like that is, OK, I want to extract this. Extracted. Actually extracted all the occurrences. I want to extract, oh, this is very common. I want to extract the 34 occurrences. Oh, actually, wait, I messed up the name. Let me rename. Oh, the latest one wasn't visible, but it's F2. I don't go and do a search and replace that could not use the AST. But basically, it will be reliable with F2. Finally, this, actually, I want to inline. And I'm going to revert this, so I inline. You see that way to express? This is what I really want you to practice. And I have a link to I have listed exercises that you can use to practice. Because no matter how long I talk about it, the only moment you can reach the extract inline fluently with your code is to make it part of your muscular memory. It should be, so you need to practice, in short. But I have exercises for you in increasing order of difficulty. Okay, let's go back to the presentation. We have our 3 core refactorings. Now let's use that to see another one that is not necessarily automated. This one, if it's not automated, I understand it's a trickier refactoring, but you're going to see that we're going to compose just what we have seen before to do something more involved. So we want to change the signature of a function. This is also something quite common. Let's consider this function, add reservation. It takes 2 parameters. The thing is, with whatever new feature we're building, we would like to add another parameter. And then we are like, OK, that's too many parameters. Let's make it take an object instead. So it's single parameter. Yes, but this function is used at many different places across the code base. So how do we do that safe? You know the drill now. So first, we're going to use extract function on the body of this. So we're creating new code. We're creating a new function, actually using another refactoring. So you select all of this, you do extract function, bam. You give it another name. It doesn't really matter at this point. I like to use a name that I could eventually search and replace if I don't have access to F2, but it doesn't really matter. The point here is we have created a proxy, just like before. So now, this new function that we want to modify, there is only one usage of it. So it makes things easier, regardless of where this other function is used. OK, so we're going to adapt. This is the moment where we can adapt our signature to whatever we will like. And once we're happy with it, the code is still working as before. So now, we're going to apply inline function to the previous one. And hopefully, this one also should be automated. So you inline all the occurrences. So you go to every call site, replace that with whatever is inside until you're done. Eventually, this is not used anymore. Only the other one, the new one, is used with the signature you want. And this is when you delete the code. And finally, we rename the function. So extract, inline, well, extract, do whatever you want. Inline, rename. And you have changed the signature for whatever you want. Again, always the same thing. Create a new thing, replace occurrences, remove the old code. You can stop at any time if you take it that way versus you change the signature right away and now the code is broken and you have to spend you don't know how long fixing everything. It leads me to one interesting observation. It is likely, when you're refactoring existing code, that the intermediate steps make code more complex. And that sometimes prevents people from doing this because there is this giant leap they need to take. And it's too big, so they don't want to take it. I understand. And we tell them, well, take a smaller one, do it in smaller chunks. Yeah, but the smaller chunk, it's worse because now we have 2 functions. We have this duplication, and the code is in an intermediate state where we have the old stuff and the new stuff together. And if you stop in the middle, yes, it's worse. The thing is, if you start doing that, you need to go to the end or revert. You don't stay in the middle. It means you can still stop at any time, but you should keep pushing forward. However, if you trust the process and you keep pushing forward and you keep doing it as you go, eventually you will reduce the complexity. This is a talk by Sandy Metz from 2014 that I really recommend. It's using Ruby on Rails, but it doesn't really matter the language. She really highlights how it looks on a very large refactoring of a code base. So I encourage you, if you are curious, to go watch that presentation. Change signature, so IntelliJ automates that. In Abracadabra, I also do support some of it. So I put you the shortcut, but you will experiment. We're done with the core moves that apply to everything. Now we're going to focus on two refactorings that are specifically designed for you have code, it is not tested, you need to write tests, but you can't. What do? And we're going to use what we have seen before. Of course, that was the goal. So this probably looks more realistic. Before it was more toy example. This is more realistic-like. It's actually TypeScript. I missed the types here, but it is TypeScript. It's an Express.js application, whatever. So this is an endpoint slash prices, a get method. And this is how you would define the controller, really. Why this code will be a bit harder to test? Because you can see that there are nested if statements. I actually have the actual code. It's even worse than this. I simplified it. There are some calculation going on. I can tell you there is a dozen. If you want to cover all scenarios, you will have to write at least a dozen tests. Tooling is getting better. So you have tools and you have ways today to test that kind of thing. In general, people will try to call the endpoint, so run the server, call the endpoint, see the response, like having a larger view of the test, and that's fine. I think you should at least have one of these tests to verify that things actually connect correctly. You know these memes with the 2 unit tests that are passing, but the integration doesn't. So integration test will be useful. However, do I really need to test 12 times that, yeah, when I call that get endpoint, it is processed by the framework and testing framework code, really? Because it will be slower than if I could just test pure logic. At a matter of, instead of having a test that runs in a millisecond, I will have to wait maybe 100 milliseconds to have all of this setup going on. Sorry. The problem is things outside of our control are making that painful to test. And here, it is the framework code. So the request comes from Express. We don't really have a word on this. We have a type about it, but it is used everywhere. It is sprinkled in the logic. Same goes with the response, actually. These are coming from Express. They have their own interfaces, but we're using that everywhere, which makes sense because we need that to make something that communicates with the external world. However, these are making the code hard to test. Even if you were like extract the whole body in a function, now you will need to pass an Express request and an Express response, especially with TypeScript. Otherwise, you won't compile, you won't be happy. And these things, you don't create them. If you try to mock them, it's going to be annoying because they are very large things. And the truth is, we don't really use all of it, only a subset. So distill and extract, the idea is to distill what is annoying to test, what is outside of our control, from the rest. Because you want to be able to extract the pure business logic. And so if you could move up or down the framework code, it will be convenient. So let's do that. We use extract variable. Actually, I'm going to lean on extract variable a lot. Extract variable on these, so age, and then the type, and then the date. And I preserved the highlight to show you that where the framework code spreads. So we still are using it. But the rest of the code doesn't refer directly to rec.query. OK. Now we have res.json. In this particular scenario example, we could push it down, and I introduce an intermediate variable that collects the response, and at the very end, call res.json with the response. That will probably be the better design. However, that will be using refactorings I haven't showed you, and I'm going to just lean on the one I've shown you because they're automated and they're safe. So I'm going to extract again. In this case, I extract a function. Difference is I keep it here because this is where I have the response object. So I extract a function. The .args is just saying I'm going to pass wherever you send me to res.json. I'm a proxy here. And I'm going to replace all of these. So I have done extract variable, extract function. Now I have this code that is the same as before. but it's just pure logic. And this code, oh, what, sorry. Well, so I extract it. Extract function again. What's the name of that function? If I'm not sure, I could call it applesauce first. But in this case, I know what it is. It computes the cost, and it also sends the cost. That's why I have the name compute and send cost. This is deliberate. I didn't just call it calculate cost, which is what I would like to do, but it does two things, which makes me think I would need to refactor more, but that's going to be for later. So extract variable, extract function. The code below, this is pure logic. Now I can write tests about it. I just need to provide a function that takes the response, and I will be able to do assertions on that. And I need to provide an age, a type, and a date, and I don't care exactly where they are coming from. This is the framework code that will stay in my application and that I need to make that logic work and being exposed via Express. And this version of Express, if tomorrow I upgrade Express and they change their types, I don't have to consider all of this code, just the glue code, really. So there you have it. Logic is hard to test, and notice how we have distilled to the top the framework code and extracted the pure logic. This is something I use all the time, and it's just enough refactoring so you can start writing tests. Sometimes you are in a scenario where it's not convenient. So I'm going to show you another way. Extend and override. So same game here. We have a class. What makes this code annoying to test? It's not that annoying with the tools we have today, but we have console logs in the middle. These will add noise in our test report. And sometimes it's fine, but at scale it's annoying. So what people do is they tend to mock the console log object and just shut down all the console logs, so no more noise. But sometimes it affects either the test framework, or sometimes you may want to use a console log at some point to test something, and you don't have console log anymore because you shut it down. So what do? There is another way. Could we do distill and extract? Yes, but distill and extract will be preserve whatever we have, distill the business logic, and move it somewhere else. In this case, we actually want to do the reverse. This is our business logic. We have annoying things in the middle. Let's move them out. So in this case, we're going to do extract variable. I don't have to do it, but if I was extracting the console log right away, it will come with name plus was added, and this is not what I want. I want to extract to the bone. Right? I don't want to take some meat business logic with my extraction. So if I have things like that in the middle, I'm going to lean on the automated refactoring to get the bone to it. So I just want to fake the minimal amount of code I need and keep as much logic as I can. Extract variable, very useful for that. I don't care about the name because it's going to be temporary. Once I've done that, extract function, in this case extract method because we're dealing with the class, but the logic is the same. Finally, inline variable. So just to show you that you can play around with the extract inline to move on. But to do that, you need to be familiar with it. Okay, that's cool. We have removed one console log from the original code. Let's just replay the other one. And now we have the same behavior as before. But we have created what Michael Feathers called a seam in his book. A seam is really, it's a way for me to alter the behavior of the code without changing the source code. With a class, I can easily do that by extending it. So don't lean too much on inheritance, of course. Don't want to have brittle, long line of inheritance. But in this case, again, our goal is to bring that logic under test. For that, I'm going to create a testable game in my test. Once I have extended it, I can override, and this is where the override is coming from, the method that is annoying, so log in this case, I could even do some custom implementation that could be convenient. Maybe actually I would like to see what has been logged. And now I can. It's actually easy. So you end up with this. You have extending the base code. You have your seam that you're overriding just for the test. And many people won't be happy with that, and I won't be happy staying with that. It's just the first step. Now I can test the game logic. But the refactoring is not over. This log method should not really belong to the game class in the first place. We have started to extract what is a different responsibility, and there probably should be some logger class at some point where we would move that responsibility. And at the end of the day, we will have a game class that we inject a collaborator that deal with logging, and in test, we just take that game class and inject another kind of logger that we can assert on. And we don't need a testable game class anymore. This is temporary. I also know that JavaScript developers, when they see class stuff, they're like, yeah, my code doesn't look like that. We don't do OOP here. Just use functions. So your example is not really helpful. How do I do that with functions? It's the same, really. You can do that with functions. So I'm going to show you how to do that on a function. Again, hopefully realistic looking code. We have a function. Annoying code, console log. We also have a, be careful with the async await operation. Usually they smell that there is something under the hood that reaches out to a third party or your database. In general, this is when things can be annoying. So what do? Extract function on the console log, same stuff. We need to be able to have the reference. So I'm extracting it outside of the function. Then I use a change signature because I want to provide another log method potentially, and this is my seam. So if the only thing you have is a function and you don't have like a class, the parameters of your function are the things you can easily tamper with. So that's what I'm doing, and I'm not changing the behavior of the current code because I'm making it optional, and I default on the default implementation I've extracted. So still a refactoring, but now I have an opportunity to change it. I do the same with all the remaining stuff. So the console log, I can just reuse the log. For the other one, it's actually easy because the function is already here, but instead of depending on it directly, I'm going to inject it as a dependency. So at least now I can start testing the logic. But again, I would not be happy just having things like that. And this is only having 2 extra parameters, but you can imagine the list is growing. There are 2 comments I want to make here. The first one is it's not over, of course. Once you have the test, now you can start redesigning your contract and your interfaces. If you have too many parameters, it probably means your thing is doing too many things also. So you may think about how do you split the responsibilities. It may also sound like you're mocking, and you may be mocking a lot of the collaboration. Ultimately, you should not be mocking too much, only the annoying part. If that code was calling another function that will do, or the class, because it's more obvious with the classes. People, when they're testing the method of a class, they are mocking all of the collaborators that are injected to their class. You probably should not. Only the parts that are annoying. The rest, you should test things going together. So this is called sociable unit test. But I know unit and integration test, people have different definition of it. In front end, they actually call that integration test. They don't make the difference. But yeah, it's a topic for another talk. At least you have these 6 moves. It should allow you to do that. Basically, refactor as you go. Because in my experience, you never have time to stop and refactor the code base. And knowing how to quickly refactor code with shortcuts and with these 2 recipes allow you to not have an excuse to just go ahead and improve the design, make things better without having to stop really as you go, because you can stop at any time. That's the trick. You're not in a broken state. However, don't stop without having the new wheel, because it's going to be trouble later. And don't do too much at the same time. But these are techniques you should use. You have a cheat sheet of these refactoring shortcuts. And a couple of things, just going to mention it to conclude. So Martin Fowler's refactoring book, this is the same, but like 60 refactoring moves. Refactoring Guru is a website goldmine in terms of resources. You have a lot of these moves, but for free in different languages. I wrote some stuff about legacy code, and abracadabra, if you're using VS Code, I encourage you to do that if you're doing JavaScript. I have only touched the question of at scale, but is Justin here? So there is, yeah. So Justin is going to do a presentation later about modern. It's really interesting if you have, if you're doing Java, Python, JavaScript, etc. They do the same kind of thing, so safe transformations, but at scale. Like imagine you have thousands and thousands of things. They have recipes that they apply automated. This was more of a day-to-day hands-on. And finally, this is where I have this coding exercises. So if you really liked it and you want to practice, go check these exercises. There are sandboxes you can use. Thank you very much. You have the slides here if you want them.